uh, now today is the one class where if you want to put the speaker on and go to take a nap, today's it. Because there's no homework. B, I think there's one or two questions on the exam, which we're going to review anyway, at the end. But this is very didactic. I mean, we kind of ramp up. The purpose of the homework was, to make sure we were in sync on how to use math practice, because we're going to continue to, use math practice to, I'll show you how to do something, go try it and bring it back to me. So we start out fairly easy, then we'll get in, a little bit more difficult as we get into particularly the analyze phase, when we get into some of that stuff. But without further ado, I wanted to switch my screen over. And if I log out, if whatever happened last time, guys, with my internet or whatever, I will just record this, and send it to you, because it's very didactic. There's no homework. It's about project management, a lot of it. We got to blow through it as far as the certification goes. So without further ado, here it goes. So here's first time, I think, in I don't know how many 100 people been through this class, maybe, or more. Everybody got the homework. Everybody, which is never happens. I usually got to chase a couple people down, but thank you so much for that. Thanks for taking the time. I apologize again for last week. And this is like Michael Basicchio when he was in my class at Central Connecticut. Sat in the front row, was always 10 minutes early, always tries to get like an Eagle Scout Award. Will you take us through this, Michael? I just love it, the amount of time you spent here.
Oh, the methods of my madness.
Yes.
And
you know what? There's others like that. Lexi, there's a bunch of others I could have put up here. Okay.
Yeah, totally. Yeah, totally. So I followed your instructions you posted on the right-hand side to generate that Pareto chart you have listed here. One of the things I did a little bit differently is I took one extra step and I added that gold bar to help visualize the what should be the 80-20 rule. But as you can see, and as we found out doing this assignment, your budget does not follow that whatsoever. It's broken. So I point that out. If you scroll below, I point that out in my ramblings, my notes, where you have a situation where more than 20% of the expenses you have listed in your budget represent 80% plus of the cost. I think like 83 or 84%. And what I did as well, if you want to scroll back up, is I actually colored in those different expenses that are to the left of that gold bar. Just again, another visual aid to help represent the problem. So I would say, if I had to guesstimate it, and I probably wrote it in my note, of the 14 or so listed fields, around 8 of them are to the left. So 57% of that data, I think, something like that, is representing 80%. And one of the assignments you gave us, and one of the discussion questions you gave us, to think of possible solutions to help remedy this and make this Pareto chart a little more accurate. So I came up with a couple of ideas, and they're not perfect, but one of which I was thinking about was, if you looked at the expenses, a lot of them could be consolidated. For example, you have 3 or 4 different costs associated or expenses associated with travel alone. You could easily group those into a parent one if you wanted to, or you could take the same thing with food as well, whether it's eating out or groceries, and that can help the situation and help visualize data a little bit better if you wanted to. So Bill, if you scroll all the way to the bottom, I think I kept the Pareto charts and I experimented with that idea. And it's not perfect, but the red line represents what that gold bar did, and you can see it gets a little bit better. So it's a start and it's a step in the right direction. Another thing you can do as well, just visualizing and looking at the different expenses, is you could drill into the data a little bit more. For example, Bill, you have miscellaneous listed as an expense. We don't know what that is, and that's probably something that you could dive into a little bit more. Or even if you wanted to drill into some of the different things they have, like phone/internet, that can help as well. That's not perfect solution, but it's just different things you could do to help represent the data better and get the results you're looking for.
That's
Um,
absolutely beautiful.
and as for the budget itself, that was another thing that you had wrote there to make a recommendation. You know, I listed a couple general ideas, even including you have $5 a month going to savings. You know, you keep that saving in general is good. Build up that emergency fund. Those Abe Lincolns will hopefully build up over time. You throw that into a savings account, life will be good one day. And then I even wrote down a couple of other ideas to help represent the data maybe a little bit differently. Maybe you increase your income, you get a second job, you start a side hustle, or you decrease your spending, whether it's you stop eating, stop going out and going to restaurants. You could really start to tackle some of those other costs. Just general ideas to help you better budget and to help tackle that red number that you're in the hole by. So just a couple things, couple ideas. They're not perfect solutions, but maybe it's a step in the right direction.
I think I find it interesting, that you were able to get to close to 80. Now 20% representing 80% just by consolidating. I think that's kind of where I was headed with the question, why isn't it working? At Duraflex, we had probably 2,000 different product offerings and then plus custom ones. And part of the idea of setting up a supermarket when we get into lean, next week, is we want to have 20% of our products represent 80% of our sales. And we want to have those 20% of that 20% that represents 80% of our sales available immediately. So in other words, a customer can call and we can ship it that day or the next day if we want, whenever they want it. We have it for them. We can't do it for everything, but the idea is what are the 20%? And I found that all new products, things that were invented a year, 2 years, didn't exist before that, it doesn't hold. You can't even put them in. The idea here is these categories are pretty general. And Michael went a different way. I would have probably looked at things like, some of these categories and find out what is miscellaneous. Because that might be 4 or 5 items that are 200 of this, 100 for that. Maybe it's, all my, what do you call them? Netflix and HBO Max and all that kind of stuff. And those get broken out into smaller pieces. Then it would head towards 80, the 20% representing the 80 most likely. But I don't know. Everybody did a really good job on this, and I really appreciate the time you took to do it. I know it's silly, but I hope you liked it. Well done. Well done. All right, now listen. If you're having trouble sleeping over the last few nights, this is a good time to tune into this class. And again, it's not like this the whole way, I promise you. So where we left off last week, we got into what's the MAC, which is probably, it's something that we want to ingrain, whether you're PTA or Albrecht Steel or even you, Dan. When you're doing, even if you're doing A3, define, measure, analyze, improve, control, and spend all of our time in define, measure, and analyze, particularly define and measure. Because if I do those two things, and that's kind of like I've had Michael Rochelo, for example, PTA. He said to me, "Well, how do we deploy these green belts, right, on teams?" Well, a lot of it is making sure keeping everybody slow, because everybody wants to jump to analyze and improve, or sometimes straight to improve, which we call jumping to solutions. Right. So the heart of this class is in the DMAIC, right? And that Y is a function of a bunch of X's when we're looking at process improvement. And we talked about what is Six Sigma, a little bit of history. We went through the roles, how to select a team. And again, keep in mind, that when we're talking about a certification here, we're talking about these 8 or 9, 10-month Six Sigma projects, that are going to yield a couple $100,000 in savings. And we're going to talk today about cost of poor quality, and you'll begin to see how easy it is, to take some of those costs and turn them into profit. Okay. But the project team selection is, again, it's a long-term project usually. And I tell you, I encourage you guys as you continue to develop as continuous improvement people, find a 1 or 2 Six Sigma like projects that you might want to tackle. Good ones are scrap. Scrap's a great one all the time, right? Um, Anything like that, something because you could basically put money back to the bottom line with that. We talked about the voice of the customer and what's critical to quality, and the Y is a function of a bunch of X's. The good news again is my output Y, what I want from my process, it's only really a function of the few vital factors, 3 to 5 things. Now we just got to figure out what those things are, and then we need to control them, and that's what Six Sigma is. We talked about, and again, the define phase is about making sure let's find a good project to work on. And a way to do that is using things like affinity diagrams, Pareto, things like that, where we're trying to understand what is the voice of the customer. I think I mentioned last time, an example was I would have never guessed that the biggest problem my customers had with my company was when they had to place an order, they had to go on hold or they had to go in the voicemail, and never would have, unless you ask them. So, there's a bunch of different ways to get the voice of the customer and figure out what's critical to quality. And that's kind of what we want to zero in on as we go forward. Those are the things we want to improve. The things that our customers don't care about. And there's a lot of things that we think they care about that they really don't. Because I think we want to get into the habit now of figuring out how do we delight and not just simply satisfy our customer. Our customer is happy if things are on time, things are good quality. That's what they're paying for. That's what they expect, especially when we consider that our competition is now Amazon, and the best companies in the world, because that's who they are used to dealing with. So today we're going to cover a cost of poor quality, some basic Six Sigma metrics that have to do with quality and the cost of poor quality. Then we get into the sleepy part, business case and project charter, cost benefit analysis, and I may touch on project risk management. Next week, believe me, I have tried to consolidate this to 2 weeks of define phase, and I could hear the snoring through the Zoom when I try to get through more than this. Next week we'll hit definitely FMEA, which is one of my favorite tools, failure mode and effects analysis. And then we're going to go into the 14 principles. And for a lot of you guys, it's going to be a review. But we're going to get a lot more lean next week. So any questions, just pop it up. No problem. Don't have to wait for me. So let's talk a little bit about the cost of poor quality. And the reason I wrote this comment here is sometimes we look at our processes at 20,000 feet and assume that everything is hunky-dory, right? Because the phone might not be ringing off the wall. People aren't enraged, our customers aren't enraged at us, but there's a lot of waste in plain sight. And part of the trick is learning how to see it. And Six Sigma is no different than lean in that we want to kind of get down to ground level so we can look at exactly how much money are we spending, either the cost of poor quality or the prevention of poor quality. And for those lean people here, a lot of times it involves the waste of over processing, doing things that our customer doesn't really care about. They don't care if something gets inspected 100 times or once. All they want is a good part, right? That's all they want. So here we go. This number is at first, it's a little bit scary, but it's the expense incurred due to waste, inefficiency, and defects. And some of them are very in the face kind of things. Customer complaints, for example, scrap, things like that. But there's so much more to it, as you'll see. Let me make this that way. So the cost of poor quality is defined as the expense incurred due to waste, inefficiencies, and defects. And it can be staggering when you start digging a little bit deeper into money that's not going to your bonus, money that's not going to your PTA's employee-owned business, right? So every dollar that I'm talking to Desiree and Lexi here, they have a big stake in profitability of the business, and this is all things that we do that take away from that. And again, the estimates are 5 to 30%, and generally, it's in the 20 to 30 range, more so than the 5. It's a symptom, not a defect. Um, a significant portion comes from the effects that are difficult to quantify and must be estimated. It represents the financial opportunity of your team's improvement effort. All right. Like when we start talking about lean, all we think about in lean is time management. That's it. That's what lean is, right? When we're talking about Six Sigma, we're looking at data, right? We're looking at numbers. But really, yeah, we are looking at numbers with lean, but it's all about time management. And that's where that um it's like estimated, I guess. Um Calculating it is iterative and will change as you learn more about the process. But there's four basic types, categories of cost of poor quality. The costs to prevent errors, like error proofing devices, supplier certifications. I mean, these are things that, if you remember from lean, people have been through my lean classes. There's value added work. That's what your customer pays for. And it's usually a coil of steel, or it's a box of parts, for IDEX or for Zoll or whatever. They don't pay for any of this stuff. It comes out of our end, right? Supplier certification, design for Six Sigma, like all the stuff that goes into developing a part or product. There's detection and appraisal costs, auditing, sorting incoming parts, repaired material, um, internal cost of poor quality, quality control department inspection, inventory. Inventory is one of the biggest opportunities because if you think about it, none of the work that we do to verify our inventory, to cycle count our inventory, to count our inventory, to correct our inventory, customer cares about. None of it. They really don't. So one of the first things we do as lean thinkers, and it did in my business, is what we call lower the water level. Our inventory went from almost $3 million finished goods and raw materials down to a little over 700,000. And that's all cash. It's sitting in our bank account instead of sitting out on the floor. And then the external cost of poor quality are the ones that are the most obvious and in our face: warranty costs, complaints, and all the work that has to go into resolving complaints. Sometimes in my situation, we're doing construction sites, we're on planes, going to look at a job, taking pictures of a job, getting samples, bringing them back. And so there's a lot of, these are the four categories of costs there's probably more, but those are pretty easy ones. Just as a reminder, like all of these are costs of poor quality, if you think about it, right? And these are what we're going to be talking about more next week when we get into lean. Defects, obviously there's costs involved. I can't just ship them. I have to redo them, rework them. I have to put them aside. I have to go to MRB. MRB is totally non-value added. There's nobody other than the learning that might come from it, unless we're learning the same lesson every day, right? Like in other words, I always used to feel like we're taking the class over and over. In that case, there's something you can garner out of MRB, but largely, defects, overproduction, making more than the customer needs right now, that's waste because it causes all the other ones. It causes other orders to have to wait. Things that go into inventory are materials are waiting to get sold. Raw materials have already been spent, and they're waiting in inventory to get paid for in the finished good. Non-value added processing, again, this is one where you're looking at 4 or 5 people getting their eyes on something, over inspecting, sign offs, days only inspection, when you can run things only on days only, 100% inspection. These are all non-value added things that our customer will not pay for. Unnecessary transport, moving things to the warehouse and back. Inventory, obviously, that's sleeping money. It can get damaged. It can get lost. It has to be counted. There's a whole bunch of costs here, in non-value added work, or what we call in lean MUDA. There's unnecessary motion. If people have to walk the printers, there's all kinds of unnecessary motion. People, if you think about it, walking to a file, walking to a copy machine, walking to get instructions, going to find the supervisor. These are all things that, in lean and continuous improvement, we think of as this huge cost. Probably 20 to 30% of our revenue is poor quality. And then the most important one is, and I think this is a thing of the past, and that is employees underutilized. All right. I think we've gotten a lot smarter. It's no more punch in, go to your machine, punch out, go to lunch, come back, punch in, go to your machine. People are not robots. People are involved in problem solving and improvements. Um, Again, these are all the costs of, if you're not doing that, it's definitely contributes to the cost of poor quality, because we're not training people, we're not using people to their potential, developing them, make them a lifetime partner. So prevention costs, one of the four types. These are costs for error proofing methods, process improvement and quality programs. Yeah, I'm non-value added. I think they keep me around though, because I must be nice to work with or something. I don't know. Cost for training, like this one, and certifications. Any cost directly associated with the prevention of waste and defects should be calculated. So if you take on a 8-month project, this is part of the define phase, is going through and doing a really thorough accounting. It might take 2 weeks maybe to get all these costs together, right? And then, when you add it all up at the end of the 8 months, that's where you start to see these big companies where they're saying, well, we saved $300,000 or $800,000 or $1 million. I mean, detection costs or quality control checkpoints, particularly over processing, where someone checks something, it goes to the next area, it gets checked again, and then it goes to the next area, gets checked again, and then ultimately the quality department checks it, right? And there's tools like quality at the source, and on that are meant to combat the cost of detection here in terms of quality control. Cost of sampling, cycle counts, and inventory accuracy. I mean, that is, the beautiful part about lowering the water level. And if you're a lean company and that's part of your lean strategy, it has to be part of what you do, right? It's we buy. I mean, ultimately, when we get the flow, it means we sell one, we make one, we use one, we buy one, right? And with that comes, we might have small supermarkets of items, but we don't have warehouses full of inventory, because now we have to keep track of them. We have to make sure they're good on the computer system. All right. In my company, you say, well, we got 4 5-gallon pails of blue. We go out there to be 8 or to be 1. I mean, constantly fixing it. So by lowering the water level, one of the first things we saw is our year-end inventory went from 2 days with everybody, with pizza parties, the whole 9 yards. It went down to like morning, because we're counting things pretty much every day. Everything was getting counted pretty much every day. And so that's the detection costs. And then the internal costs are post-production quality check team, time and tools to audit things. I mean, I hate to say it, ISO is probably, it's a non-value added cost, and testing, destructive testing, anything that's associated with the identification of waste and defects before a product shipped to a customer is in the internal costs here. And then the last is the external costs. Those are relegated to obligation, or those associated with addressing the waste that, God forbid, reaches the customer. I always think about Chris Rock, it used to be fashionable on our websites to say, we have great quality. Well, Chris Rock used to say, remember, he used to say, I read to my kids. You're supposed to read to your kids. You don't get a cookie for doing things you're supposed to do, right? So these are all things that we're supposed to do, like repair costs, warranty costs, replacement costs, customer returns. And then it's hard to even put a number to lost business because of these types of costs that, you ultimately pay 2 or 3 times for. And, it's interesting, and it's probably a leap of faith for us lean people. And I saw it at Theraflex, is the closer I get to flow, automatically quality improves. In other words, my cost of quality decreases, morale increases, my profit increases. And I think we saw that for my PTA friends on that the IDEX Cat 1 line. But it went from eight parts an hour, 8 to 12, to 36 per hour. And all of a sudden, there's no more repair costs, warranty costs for that particular part. And now we're looking to do it again, with something with another part. But the closer you get to flow, these all disappear magically. And it's a leap of faith for sure. And there's two types of costs that we need to consider. One is hard costs. Those are costs that can be traced right to the income statement, and soft costs. And this is kind of where lean is. Lean's in the soft costs because, a lot of times we're eliminating 80 hours of something, especially for my Ulbrich friends. You guys see this all the time. It's like the amount of time that you're eliminating from processes. All right, well, how do I put that on the income statement, right? These are intangible. But largely, again, lean is about time, but it's also a business strategy where if I'm a $10 million company and I have, let's say, 20 employees, the goal is to continue to take time and waste out of our processes so I can be a $20 million company with the same number of people. That's the key, because they're not doing all of that wasteful work that we were talking about with the 8 wastes. So to calculate it, determine the types of waste, estimate the frequency that it occurs, estimate the cost per event, item, or time frame, and then do the math. And I think I see the Ulbrich people are really, really good at this, because you don't need to get down and, stopwatch is good, but I don't need to measure every single instance. So we're able to learn some, and kind of interpolate it out and understand that in a lot of cases, walking to go get a tool 5 times a day translates to someone walking 20 hours a year or half a 40-hour shift. And that's the beauty of doing some lean math too. Any questions about cost of poor quality? I told you it's boring, right? Are everybody awake? I hope.
Still here.
All right, Alex. Alex is awake. All right, so let's get into some basic Six Sigma metrics. And I know we covered some last time. We're going to continue to keep adding, but there's a lot of them here that we're going to cover in the future, like a Sigma level, process capability, tack time, cycle time, all that kind of stuff. The ones we're going to talk about today are quality product. So again, we're talking about a good unit, one that passes inspection. And there's a difference between a defect, says no defects. A defect is an opportunity that is unacceptable and unusable. So in other words, I might have one part that has many defects. A defective is a unit that has at least one defect, rendering it unacceptable. All right, so you have a defective part, and on that defective part, we could have one or more defects. And again, these are not on the exam, so I'm just telling you that I could tell you, I tell people I told you. So scrap is output units that are defective and cannot be reworked. And rework is initially unacceptable, but once we rework them, they're good to go. And opportunity, that's any point that can be inspected for pass fail, right? And that can be from the first step to the 10th step. Those are all opportunities, and we might have multiple opportunities per unit or process. A unit is a deliverable. And a couple of other lean Six Sigma terms. One is DPU, defects per unit. So in other words, if I have a defective part, I might have more than one defect. I might have, in PTA's case, let's say I have splay, contamination. I could have multiple defects per unit. It's the basis for calculating defects per million opportunities or rolled throughput yield, which we'll cover in the next couple pages. DPU is found by dividing total defects by total units. So if you have a process step that produces an average of 65 defects for every 598 units, your DPU is 65 divided by 598. Now, here's where it gets a little bit fun. Calculating defects per million opportunities. We always do, because once you get to Six Sigma, then you need to look at a million opportunities and not defects per unit. because the number of defects is so low, you're looking at 0.000 something. All right. The equation is pretty simple. It's the same as 6 defect opportunities per unit, 4 defects every 100 units. So I got 6 defect opportunities times 100 units. That's 600 opportunities. The defects rate is 4 defects every 600. And then I multiply that times 1,000,000 just so I have something a number I can get my mind wrapped around. Because if you remember this chart in this DPMO in parts per million opportunities, when I get to 6 sigma, it's only 3. What did the knucklehead just do? 3.4 defects per million opportunities. Really, I mean, if you get to that level of consistency, lack of variation, we have to measure it in defects per million opportunities. And here's the significance when it approaches 6 sigma, and it's for resolution in the measure. Simple as that. So yield and first time yields the percentage of units free from defects. It's a percentage of met commitments, total of defect-free events over the total number of opportunities. First time yield is the number of quality units produced after all process steps and reworks. And we include reworks when we talk about first time yield, divided by the total number of units going into the process. So total units minus scrap is equal to good units. Good units include rework. We're going to talk about another metric that does not include rework, and that's our yield rate. And it's a very common, I think it's a really common metric for measuring quality in any process. But if you have a process that's divided into 4 sub-processes, A, B, C, and D, this could be rolling, slitting, furnace, wash line, whatever, or it could be molding, finishing, printing, whatever. Assume that you have 100 units entering process A. So to calculate first time yield, you calculate the yield number out of step number in the step of each step, multiply these together. So without all the English, let's go into it. 100 units enter process step A and 90 leave as good parts. So the first time yield is 90 divided by 100, which is 0.9. Now those 90 go into the next step and 80 leave as good parts. Now the 80 out of 90, and there's my 0.889. Of those 80, they go into process C, and 75 leave as good parts. Now I got 75 divided by 80. And then those 75 units go into step D, and 70 leave. So 70 out of 75, and there's now I just take those and I multiply them all together, and my first time yield here is 0.7 for the process, or 70%. Pretty simple, but I think it's a really good measure. I'm assuming you guys already do this in quality. Because basically we don't want to be, we don't want to be doing gymnastics to get things out the door. We want to get that thing to be as close to 100 as we can. I have an A3 that I'm actually leading right now at PTA. It's about risk management. It's a scrap, trying to look at the risk of scrap of something that seems to occur pretty often. We know it happens, and kind of taking some of this thinking and understanding how do we get it to close to 100. Throughput yield. Now this is the number of acceptable pieces at the end of a process divided by the number of starting pieces. And it's used to measure a single process only, right? And first pass yield, or the quality rate, and now we're eliminating scrapping, rerun, retested, return, or diverted. We want to know what's the probability of things getting right through. And RTY, when we get into RTY with a rolled throughput yield, what we're really talking about there is the probability or the odds, that something can go all the way through our process and have 0 defects. So first pass yield is calculated by dividing the units entering the process minus the defective units. So it's the same thing we just did, except we're not going to count the defective units. Now the rework units, I'm sorry. And roll through yield is the probability that a single unit can pass through defect free. And here's that same analysis: 100 units enter process A, 5 were reworked and 90 leave as good parts. So now we're going to use 85 here, right? We're not going to use the whole 90 because we had to rework 5 of them. So you guys got to kind of get it. But the same thing at the end, for each process step, we're going to take those percentages and multiply them together to get a roll through yield of 0.5075. Low, that's very low. More process terms. Now we're talking our language. This is lean stuff, kind of, because we're talking about time. Cycle time. What's the time required to complete one cycle of an operation? Takt time is the available production time divided by the rate of customer demand. This is also the heartbeat or the drum beat of your process. For those of you guys that have done Lego planes with me, we cover this quite a bit. And also for Desiree and Lexi, we also did this with the Cat 1. We figured out what the takt time was and what was the takt time of each individual station. And for Brent, we also did it on the Caldwell a couple of years ago when we kind of doubled or tripled that output. So single piece flow means proceeds through various operations without interruptions or scrap. That's flow. And the 8 wastes is what interrupted. And then standard work is a precise description of each work activity, which specifies cycle time, takt time, the work sequence of specific tasks, and the minimum inventory required. Right. Project management basics. This is where if you're going to close your eyes or put a podcast on or something, there we go. It's the process of defining, planning, organizing, managing, leading, securing, and optimizing resources to achieve a set of planned goals and objectives. And again, this happens on a real smaller scale with your A3 process. It's obviously not as drawn out as what I'm going to take you through. It's the application of knowledge, skills, tools, and techniques to project the project activities to meet requirements. Project management. I have a whole bunch of engineers on this class, so you guys are very intimately familiar with project management. I think we have 5 or 6 on this class. A project plan is a crucial step. It's a formal approved document. So again, with this 8 or 9 month Six Sigma project, it takes a while to get it together, right? And it's a lot of work to get it together. And again, I think I mentioned last time, for those of you guys that are familiar with A3 closings, this when you're doing a Six Sigma project, each phase is closed in front of management, for approval of stakeholders, the whole 9 yards. So this define phase might last 2 months, and then the measure might be 3 months, and analyze might be 2 months, and this one improve might be a month, and control might be a month or a couple of weeks. But it gives you an overall framework for managing project tasks, schedules, and costs. It's a coordinating tool, communication device that you keep going back to just to make sure that the project doesn't creep away from you, which can easily happen. The activities are a statement of work, a work breakdown structure, resource estimation plan, a project schedule, budget or financial plan, a communication plan, and a risk management plan. And the statement of work is a formal document that outlines specific expectations. What do you guys call it? PTA management review or management expectations, something like that. But define the scope, establish the expectations and parameters, identify technical requirements, provide guidance, establish timelines, kind of the roadmap, if you will, of what you're going to be doing. And the work breakdown structure, it decomposes the project components into small logical bodies of work. And the way you do that is you identify all required components, cascade components into subcomponents and tasks. WBSs are not project plans or schedules, but they are a necessary step to help us establish project plans and timelines. And I'm going to give you an example of building a bicycle. So here's a work breakdown structure for the assembly of a bicycle. So level 1 is the bicycle. Level 2 would be the frame, the wheels, and the brake system. And level 3 for frame, for example, would be set body frame, assemble handlebars, install seat and post, assemble wheel bearings and axles. But it's taking a big project. And again, in terms of A3 thinking, we're going to take something in level 3, it would be part 1. Then we take assemble handlebars. Then we take the best way to install the seat or improve how we install the seat and build it up to the frame. In other words, how do we eat an elephant? One bite at a time. The resource estimation plan, it goes with your WBS. It's parts, hardware, software, planning resources. So set body frame. I need a body frame. One of them is $9. Part inventory is $4, and who's responsible. So it gets more and more linear, or a little more granular. I mean, as you go through this WBS and the resource estimation plan. A lot of times, like these big companies, when they're taking on this define phase or a big project, they have to submit an ROI for the project because there's a lot of resources and cost. From a lean standpoint, again, I'm going to kind of point out a lot of differences between lean thinking and Six Sigma thinking. And lean thinking is if you're spending money, you're probably doing it wrong, right? It's not about spending money. It's about taking things away more, right? And then you do your project schedule, a Gantt chart, its ability to display the status of each task. You guys may be familiar with Gantt charts. Kind of gives you a duration for each step. I use a lot of this. One of my customers is a construction company, so they're building a whole hospital ward out. And, the Gantt chart example would be the 6 months or 5 months of the project. And then each task by each sub. And those bars tell us when they start, when they stop. And the financial plan, planned expenses and revenues and budget and a commission. This is the biggest one. I think that's where the closings are beautiful. And some people say, it's not worth it. It's like, I don't know. It's just so important. I think that's where morale comes from, is making sure that everybody feels like they know what's happening. More people leave or quit because they feel like mushrooms. They're not part of the plan, not being informed. But same thing with a project like this, like keeping everyone, all the stakeholders, involved and engaged and understanding, able to answer questions, things like that. And then we have to have a risk management plan, and we're going to cover risk management a little more next week when we get into PFMEA. But we want to identify the sources of project risk and estimate the effects. They could arise from new technology, availability of resource, lack of inputs. A lot of times I see is, because again, most companies are running very lean now in terms of people. There's not a lot of people twiddling their thumbs, waiting to, do something. So a lot of it is getting people together, and trying to coordinate that and making sure people have the time to think, to get off the mouse wheel and actually think together. That's probably one of the biggest risks. Assess the impact of risk to the customers and stakeholders, calculate the probability. And we're going to get into this when we get into FMEA. Initiate mitigation and contingency plans and review risk on a periodic basis. Because if I'm spending this much money, it's a huge undertaking. We want to try to identify risk before it happens. And the FMEA is it's a cool process. And maybe, I can't wait to find out how many of you guys have done it before, because it's probably one of my favorite tools. You're gonna hear me say that a lot over this course because I got a lot of favorites. But so planning advantages are organize and communicate, link tasks and subtasks, objective comparison, scope, effective scope control, because as we know, can get away from you. Facilitate effective communication, define management reviews. And again, I think the way it works generally when you're doing a large scale project like this is at the end of each of the D, the M, the AI, and the C. And they're the monitoring mechanism for the project. And believe it or not, there's more. Business case and project charter. So the project charter, it's a structured and rigorous methodology to be repeatedly applied to any process to achieve Six Sigma. DMAIC was a methodology that refers to those 5 phases. And given the premise of the DMAIC, it's a good way to kind of organize our project charter. It's to provide vital information about a project in a kind of a Reader's Digest. Does that exist anymore? Easy to comprehend manner. Project charters are used to get approval and buy-in to the scope, what the teams are, who the decision makers are, authorities are, project lead, and success measures. So it's kind of like something I can hand over, and it's a report. And here's the key elements of it. Yeah, I think you can download a project charter template, and it kind of helps you, like a business plan, go through and touch all these things. It's better to think about them before, right? Anticipate and then mitigate problems. And quickly, the title, the leader. And I think TTA, we're using a lot more RACI charts, but who's responsible, accountable, consulted, and informed. A business case is a quantifiable reason why the project's important. Business cases help shed light on problems. They explain why a business should care. They must be quantified and stated succinctly. Cost of per quality is a key method of quantification. And I put, Tai Chi Ono, no problem is problem, because I mean they're all around us, right? And that's the beauty. Like, in business, it used to be really fashionable when someone says, "How's things?" Wow, wonderful, hunky dory, perfect. And then I had to go out and lay nine people off, right? No problem is problem. And I think if you look at it, you get off the 20,000-foot view and get down onto the floor, and also into the offices, there's plenty of opportunities. And Tai Chi Ono, my hero, that you'll learn about more next week. No problem is problem. Because as long as we identify it, we make it visible, we have the brain power to fix it. So the elements, problem statement and objective, again, the gap between the present state and the goal state, right? And here's an example. Process defect rates are 17%, and we have a goal of 2%. This represents a gap of 15%, costing the business $7.4 million. The goal of this project is to reduce this gap by 50% before November 2023, putting process defect rates at 9.5% and saving $3.7 million. All right. And another example, these are good problem statements. Process cycle time averaged 64 minutes since 2019. The production requirements put the cycle time goals at 48 minutes. This 16-minute gap is estimated to cost the business $296,000. The goal of the project is to reduce cycle time by 16 minutes and capture $296,000 in savings. Those are good problem statements. The metrics, key elements, again, of this is measure success. Metrics give clarity. Metrics establish how the initiative will be judged. We need to establish a baseline or starting point. That's usually in the current condition on our Six Sigma form. On our A3 form. And again, I put my favorite quote of all time: when you can measure what you've been speaking about and express it in numbers, you know something about it. When you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. And one of the things I always hear as a lean, as a lean guy, is, how often does that happen? Oh, all the time. So again, we want your biggest hurdle as green belt is going to be when you get back into those A3 teams or on improvement projects, is be that person that says, how often, how much, how long, and count or measure. There's a primary metric. It's the most important measure of success. And a primary metric is a must for every project and can't be taken lightly. They should be tied to the problem statement. They should be measurable, expressed with an equation, aligned to the business objectives, tracked at the proper frequency, and expressed pictorially over time with a run chart, time series, or control chart. And it's validated with a measurement systems analysis. We're going to get into MSA pretty deep on the next few weeks. This is very simple. Like when you're going after scrap, you want to reduce scrap. Like Ulbrich steel, I remember Chris Ulbrich said to me one time, if we can decrease our scrap rate by 0.5%, that would have been an extra $200 in everybody's bonus or $500. Yeah, they're right in his head. But we want to, whatever we're doing, we want to be able to tie that back to our objective. whatever we're measuring. And these Six Sigma people, they turn an MSA, they turn it into a science, as you'll see. So the primary metric is the reason for your work, success, it's your beacon. And a secondary metric is the thing you do not want sacrificed on behalf of a primary improvement. It's one that makes sure problems are not just changing forms or moving around. The secondary metric keeps us honest and ensures we are not sacrificing too much for our primary metric. If your primary metric is a cost or a speed metric, your secondary should be maybe safety or saving energy, making sure that people aren't freezing in the building. My favorite example of this was one year in our wisdom at Duraflex, we said we want to increase sales by 15 or 20%, I forget which. And they did. Our salespeople, we had 10 salespeople all across the country. And our discounting went through the roof. Our accounts receivable went through the roof because we didn't have a secondary metric. In other words, they were selling to anybody that had a pulse, right? So you have a primary metric, and then we have a secondary metric. And so here's the elements of a good project charter. Scope, stakeholders, etc. The cost benefit analysis, real quickly. Update the cost benefit analysis at each phase of the MAC. In the define phase, the cost benefit analysis helps understand if it's financially feasible to do the project. Because again, we're talking about big projects. In the middle phases, we want to update and review it to help compare potential solutions and make data-driven decisions. In the control phase, the cost benefit analysis helps track the project's profitability. And some examples of benefits: direct revenue increase, a waste reduction, operation cost reduction, quality and productivity improvement, market share increase, cost avoidance. These are all examples of cost benefits. And here's how we do an ROI. It's the ratio of the net after removing cost, financial benefit, gain or loss of a project or investment to the financial cost. Here's a little formula for you. And with that, the most boring of the whole class, the whole course. And everybody awake, 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 awake. Good. So I have the recording for you the next hour or so, in case you have trouble getting to sleep tonight. Put it on your earbuds, and you'll be out in 5 minutes. Any questions, guys? And I think we're right at 3:54. Again, thank you so much for your attention. It gets better, I promise. All right, have a great afternoon, people. Thank you again.